All right, this time we're going to talk about using GPT-2 with Hugging Face in SageMaker. But before we get started, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. So today we'll go over text generation using pre-trained GPT-2 through Hugging Face's Transformers library in a SageMaker notebook. Rather than training models, you'll learn about inference with ready-to-use large language model and how modern tools can simplify access to state-of-the-art NLP capabilities. So how do you understand this? All right. SageMaker Notebook instances provide fully managed Jupyter environments with compute, storage, and networking. They're ideal for prototyping machine learning workflows, running code that uses Hugging Face models locally in the notebook kernel rather than launching full training jobs. Hugging Face's Transformer library offers access to 100,000 pre-trained models. The pipeline API wraps model loading, tokenization, and inference into a single function call, dramatically simplifying what would otherwise require dozens of lines of setup code. GPT-2 is a casual language model trained to predict the next word given input token sequences. It's publicly available through Hugging Face, making experimentation accessible without special permissions or fees. All right, so when you're using this, a pipeline function will download GPT-2, its tokenizer, caching weights in the notebook, input text that gets auto-tokenized. Then it's fed through GPT-2 and returns generated completions. You can control the output through different parameters like maximum length, number return sequences, temperature, top K, top P, and those parameters, right? So why does this matter? The workflow showcases how Hugging Face accelerates experimentation within machine learning pipelines without infrastructure setup. Use cases include generating synthetic text or chatbot responses, rapid iteration on prompt engineering, baseline benchmarking before fine-tuning, and educational demos explaining LLM behavior. Combined with SageMaker training, SageMaker inference, and Jumpstart, this becomes a building block for secure, scalable API application or AI applications. My apologies. So, how would you do this in the lab? Which we're not going to do because it's time and cost prohibitive. Couple things. One, you need the SageMaker notebook. You would launch that, create that with an instance, usually the ml.t. It'll be a CPU-based instance. Make sure your IAM roles are configured. Make sure you have anything stored in S3 or in your EBS block storage there. Install your necessary dependencies, create the notebook, and run it. From there, you can execute any of the inferences through GPT-2. You can experiment with the parameters and then examine the output. And the output will demonstrate the model's ability to produce plausible but potentially fictitious content. This is a hallucination. The model creates coherent text that may not reflect reality. Once completed, you can stop the instance of the notebook, and then you can select and delete all of this. This is critical because closing that browser tab does not log out or stop billing. The instance must be explicitly stopped to avoid unnecessary charges. So, what are those charges? SageMaker Notebook instances bill per hour. The ml.t instances cost about 5 to 10 cents per hour, while the ml.g with a GPU run about 75 cents per hour. EBS storage is about 10 cents per gigabyte per month in most regions. It usually starts at about 5 gigabytes. And Hugging Face model downloads are free. You only pay for compute and storage. But remember, idle notebooks continue accumulating charges. So always verify the instance status shows stopped in the console after finishing your work. So for the exam, remember a couple of essential things. When questions ask about rapid prototyping with pre-trained models, integrating open source tools with AWS, or experimenting with language generation, understanding Hugging Face's SageMaker integration demonstrates practical machine learning development capabilities. So I hope you enjoyed this because I did. Well, before we go, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. Until then, have a good day. Thank you.